This is All Things Ansys, a podcast for the technical support staff at PADT. Episode 140, a discussion on simulating rad-hard electronics with Ansys and news and events from the Ansys world. Greetings, I'm Eric Miller, one of PADT's 3 owners, and your host here for the All Things Ansys podcast. It's 2026. We are excited for our first full calendar year working in the new era of Ansys, and so far things are off to a great start. Here at PADT, we've been very busy. Members of the Ansys sales team, and hopefully some of you ran into them, went to CES to support the Synopsys booth, visit customers, and meet lots of new companies. One of our salespeople, Harrison Aragar, did a great write-up on the trip, and it's in our blog. So I recommend you take a look at that. My takeaways from his write-up and from talking to others who were there was that the cool stuff was robotics, AI and robotics, AI, physical AI, which is kind of using AI with autonomy or robotics to make decisions and to do stuff. Autonomy itself is, of course, growing and becoming even more prevalent everywhere, and lots more with electric vehicles. A lot of growth there as well. So it was a lot of people and a lot of exhibits. And of course, Ansys simulation plays an important role in all of that. So they were able to have dozens of great conversations with people on how they can leverage tools from Ansys to get better products to market faster. My favorite part was where they were able to visit customers who we've supported over the years and see the products they are using Ansys simulation to drive the design of. They're at the show, sometimes being premiered there. So that's really cool to always see at CES. So great show. If you've never been, try and go there. It's really crowded, but it's worth it. Wear comfortable shoes, they always say. So let's go ahead and get into it. Let's change gears completely and talk about space. So going from what used to be the Consumer Electronics Show, it really isn't anymore, to space. So Ansys has partnered with a company called EMA, and we'll learn more about them. They have simulation tools that are part of Ansys now, so you can buy them through Ansys. And they have testing capabilities as well. And these tools and testing look at how charged particles and high-energy electromagnetic fields impact spacecraft. So it's basically energy in the form of radiation in orbit around the Earth, and it can get into your electronics and cause havoc. We have some customers using these tools, so we're getting kind of exposed to it. Like, so is that a pun? And we wanted to share the great capability because we're seeing so many new companies building hardware for space. In the past, it's always been the big guys, and they've always kind of understood this whole rad-hard side of things. But now these newer companies are having to figure it out, and they're using Ansys to do it. So let's learn a bit more from the experts as well as PADT's own Tyler Buntin. For the next interview that we're doing, and we're going to go a little bit back out into orbit and talk about rad-hard electronics and what we can do with Ansys tools to simulate to make sure that their electronics on our spacecraft and our satellites and things like that survive. And I'm joined today by a couple of experts in this area. Kevin-Druis Merenda is with us, and also John Twerdok from a company called EMA, which is an Ansys partner. I'll let them explain who they are and what they do a little bit more, as well as Tyler Buntin from PADT. So, John, why don't you introduce yourself and the company, and then we'll go to Kevin, and then we'll go to Tyler.
Thank you, Eric. Well, my name is John Twerdok. I'm with EMA, which is Electro Magnetic Applications. We are both a services and a technology partner of Ansys. As a technology partner, we are the developers of the solutions Ansys EMC Plus, Ansys Charge Plus, and now STK Shield Plus. We also do quite a bit of consulting, test, and measurement services in advanced electromagnetics. And as a service partner, the Ansys team works with us either as a subcontractor on larger projects or referring specialized business to us. We do have a space environmental effects lab in our Massachusetts facility, so we actually do some physical testing as well. And I've been in the simulation business for over 40 years, so it's great to be here. Thanks for having us. And I'll let Kevin introduce himself.
Yeah. Kevin.
Thanks, John. Thanks, Eric. I'm Kevin Merenda. I am the lead product manager for the software solutions out of EMA. I'm also a principal scientist at EMA. We have 3 software products, Ansys EMC Plus, Ansys Charge Plus, and Ansys STK Shield Plus. The latter two are the ones that are going to be of interest today in our discussions of radiation hardening.
Mm.
I've built a lot of my expertise through my graduate programs. I have some expertise in elementary particle physics, as well as cosmic ray physics and atmospheric electricity physics. And I've done a lot of simulations to be able to reproduce some very exciting and exotic data that we've seen in pretty large experiments across the globe with numerical techniques that are within those products that we're happy to talk about today.
Excellent. Excellent. Well, thank you for coming in. And Tyler?
Yeah, so my name's Tyler Buntin. I'm an application and support engineer here at PADT, supporting the Ansys softwares as well as the EMA tools for PADT and its customers. My background's in high-power microwave devices, so not necessarily space-related, but there's still some plasma interactions, so I have rudimentary knowledge, at least, on how these sorts of things interact, so I'm excited to learn more and participate in this discussion.
Excellent. Very good. Well, before we get started, I'll point out the fact that John and I have probably known each other since before PADT, right? I think when we were still at Allied Signal, we met the first time. So it's been a while.
Yes, it's great to reconnect.
Yeah, over 30 years. So it's good to have you on. So let's start at the beginning, which is when we're talking about satellites. Rad hardening can refer to a lot of different situations, like the battlefield and things like that. But when we're talking about satellites, what do we mean when we say rad hard? You want to take that, Kevin?
Yeah, I can take that. So RadHard stands for radiation hardening.
Mm-hmm.
In space, we have to deal with radiation in various different forms. This is very specific to radiation from charged particles that are coming from outside or inside our galaxy that are accelerated through the magnetic fields of the Earth or just the magnetic fields within our galaxy, and that are interacting with the electronic components of the satellite in various ways. And the hardening portion is about figuring out methods to be able to mitigate the effect of this radiation. And so by doing radiation hardening, we are introducing some design changes, some mitigation techniques to be able to ensure that we don't fall to the risk of the radiation effects that are coming from outer space.
Cool. Quite cool. So is it that so what does, let's say, a charged particle or a really energetic photon hits something? Is it doing damage to the structure? Is it what does it actually do to the material that we're trying to avoid?
Yeah, so when a charged particle interacts with matter, it will leave some energy behind. It will either also disintegrate inside the system, or it will just interact with the bulk material, so the molecules of that material. And that can be, for example, the silicon and the transistors inside the RAM of an electronics board, right? And so at that point, that can be very consequential. As most cases, a lot of the effects that are being generated by those charged particles can be mitigated in various ways, and some of them are harder than others.
Yeah. Well, I'm going to definitely ask about those and how we simulate them.
Mm-hmm.
So let's go ahead and dig into this. So I got a satellite and I'm putting it up in orbit. I want to understand if I have a problem. What Ansys tools or EMA/Ansys tools would I use to figure out if I got a problem or not?
Yes. So the Ansys tools that we have are going to be Ansys Charge Plus or Ansys STK Shield Plus.
Okay. And what's the difference between those two?
So Ansys Charge Plus is a tool that I would describe as the Swiss knife, with a lot of very different modules and physics tied together to be able to do more than just assess the risk of like the ionizing dose, which is typically one of the metrics that we go after when we look at radiation hardening. We want to keep ionizing dose under a certain threshold. But that radiation can do more. It can actually get trapped inside a dielectric and actually lead to a buildup of electric fields over time. And this is a phenomenon that we call internal charging. When you want to start looking at coupling with electromagnetics and more consequential response to that radiation, we have to bring in some additional physics modules, and that's why charge is relevant for some of these applications.
Mm-hmm.
STK Shield Plus, on the other end, has more automated portions of Charge Plus that are integrated with STK to be able to extract information such as ionizing dose very quickly. But the processes are streamlined, much more efficient, but maybe bringing in less physics and less accuracy in the analysis.
And can I use the SDK tool and to look at, say, my dose over the history of the lifetime of the product? So maybe it's up there for 10 years. Yeah,
that's one of the big interest of using STK is that STK is integrated with the NASA databases for extracting the energy spectrum of the electrons and ions over the mission and the orbit. And you can take that as an input to Shield Plus to be able to then look at what the dose is over the lifetime of the mission.
And because we're talking about satellites here, but because I'm a nerd, I could use this for my deep space probe to Pluto as well, probably, right?
The NASA databases are not populated for anything beyond GEO. So at that point, we have to use research papers for some worst case scenarios for interstellar space. But it's definitely doable as an input to STK Shield Plus. You could imagine that you need to build up enough statistics and have a lot of experiments to be able to extract those energy spectra properly. We don't have that kind of information around Pluto yet.
Yeah, as we go more often, we'll get it. That's pretty cool. Okay, so what kind of getting into the technical here? Are these finite element tools? Are they finite difference, boundary element, volumetric? What kind of? I assume there are multiple solvers. What kind of solvers are under the hood here?
Yeah, so the technology used for doing these type of analyses is based on what we call radiation transport codes. So we have to be able to transport these charged particles through the matter, through the geometry, and be able to model and process the interactions that are happening within the geometry, and then extract metrics like dose or charge or things like that are coming out of it. So you don't actually need to create a volumetric mesh for a lot of these bodies to do radiation hardening. You typically just need the boundary elements of each elements inside your structure that you need to analyze. Once you start coupling things with electromagnetics and you want to go further in the analyses, then that's where you have to start coupling these things to finite element method tools for electromagnetic fields.
So I need geometry. I define my geometry. I define my mission, and somehow come up with a load history that it's going to see, and then I can calculate these things. So let's talk about mitigation then. So I'm familiar with shielding because that's the little bit that I've been involved in. Is sometimes we get a little bit involved in helping people figure out how to design their components so that they got whatever shield material they pick on there. So what are the different kinds of things we can keep, I guess, to keep the radiation out and then to deal with it once it gets in there and to deal with the charge buildup as well?
Yeah, so the obvious way to kind of reduce the ionizing dose is by adding extra shielding. The problem with shielding is that it's heavy and that increases the cost of the mission, right, and the design. So the other alternatives are finding materials that can help shield without having to increase the thicknesses, things like that. The other thing is by being able to leverage 3D codes like ours, you can start working on the positioning of your components, and especially the sensitive ones within the devices on the board, and putting them in places that are more shielded than others, things like that. You get that kind of sensitivity with those tools. And then you can also start doing shielding at the component level on the PCB, not just the enclosure of the devices. You can start looking at radiation, like doing a rad hard on the IC chip on the board. These are all physical mitigation techniques. By coupling to STK, you can start thinking a little bit differently. And is there a mission that actually, like a mission path or an ephemeris that minimizes radiation in some way? Do you have to go through the magnetotail of the Earth where the particles are the fastest accelerated through the fields there? In that case, do you have to go through the radiation belts? Can you find another path because you actually are trying to be like save money, for example, on the radiation hardening front? And then most recently, which we're not solving just yet in terms of software simulation, is doing radiation hardening at the software level, right? And creating redundancy within the software to be able to deal with things like bit flips, single event upsets, and effects on the memory by having redundancy on the OS and things like that could bypass those effects.
Yeah, because unlike rubbing your feet across the carpet and touching a doorknob to discharge yourself, we can't do that, right, in orbit. So is there a way to dissipate that charge over time?
There isn't. It depends very much on the environment that you're in around the orbit. And we talked about things like ionizing dose. This is one effect from radiation. But there's also things like non-ionizing dose and single event upsets, which these things you can't really shield yourself from. You have to actually understand how that charge that's deposited at the silicon level that you can't get away from is being transported around the transistors and the integrated circuits, and how you mitigate it at that level. And that is also something that we're working towards in terms of simulations.
Cool. So, John, you're out there, working with customers that are looking at these tools. What's the number one reason why you're seeing people wanting to do this kind of simulation?
Well, I think in general, it's to not only reduce their liability, but to also increase the probability of success in a mission. As you can imagine, unlike most products, once you put something in space, it's really difficult to retrieve it and repair it. So they really look at it as a mission critical thing. And we're seeing many more private companies are putting hardware into space. They may not be the satellite manufacturer themselves. They may be makers of antennas, cameras, various mechanisms that take a ride on someone else's platform. And so they're not as accustomed to designing for this. And we're seeing an increase in that. I think more recently we've seen, and Kevin kind of mentioned it, this single event up SEEs, that happened very recently with some of the solar flares. So even though you're not in space, you're at higher elevations or altitude. And even here on Earth, the solar flares that have recently happened cause these type of events on some of the equipment here on the Earth.
Yeah, it's something we need to be really aware of. It's a fascinating area. And again, we take for granted, that we're communicating through these satellites all the time, but boy, if they go down or don't work, we'll notice, right? Cool. So what this question to all of you, maybe Tyler, I can't remember if we have any customers using these products yet or not, but what's the biggest challenge? If I'm an engineer that wants to do this kind of simulation, what's the warning you would give them? You need to be careful about this. What's the challenge they're going to face that you want to pre-warn them about before they dive into this area? No, Kevin, you may be the one that's dealing with that the most.
Yeah, I can try to take that. I think we have some pretty well-established standards that we have to meet to be able to radiation harden components and electronics. I think the one thing that a lot of people don't consider when they're like they don't often consider radiation hardening or internal charging as something to worry about, because a lot of the other satellites that are sent in LEO, for example, don't have to worry about that. But when you start slightly changing your orbit, or your mission, or you become you start having some imagination on where you could take your design further in space, then at that point things become pretty critical, and being familiar with those standards is important. And so we do have some expertise and knowledge at PADT and Ansys and EMA to make sure that you are conscious and careful about those standards that have to be met, and that the tool can help you meet.
Okay. Tyler, you have anything to add to that?
So we don't have a ton of customers who are currently using it on the from PADT side, outside of some national labs, and we do have some space customers who are doing it. And it's, to kind of piggyback off of Kevin's statement on the standards and everything like that. This is a very complex physics of everything that's going on there. So, thing that I've dealt with personally is ensuring that that the results that you're getting back are real. That you've set up your problem in such a way that you are actually getting the information that you're seeking, and not simulating an environment that you're not actually going to operate in. And so, in the most of the work that I've done in this field is related to doing some satellites in geostationary orbit.
Okay.
And so, just sort of, thankfully, there's a pre-built plasma environment for that specific orbit that comes with the software. But if you're in other orbits, making sure that you have the correct background environments and things of that, make sure that you're have the proper reaction rates between your various particles. It's a very complex tool, very complex physics. Don't be afraid to reach out and ask for help if you're doing this.
I was gonna ask. Yeah, it sounds like if you're gonna dig into it, it's best to bring along an expert from PADT or EMA or Ansys to help you figure this out, so you're not learning the hard way.
Absolutely.
How to get there.
Yep. Eric, I would add
Please.
one additional thought to it, and we're seeing that, like all simulations, you need a geometry and a design and boundary conditions and loads, but you need really accurate material properties. And so we're seeing a lot of customers don't quite understand how all of their components will react when they're exposed to radiation in that type of environment. So we see a lot more customers asking for characterization of different components, which our lab in Massachusetts does. We have space chambers there you can subject things and literally characterize them, so that if you do want to run simulation, you have an idea how they'll respond.
That actually that's really good to know, because in fact I've got some questions about that for one of our customers that we'll talk about after the podcast. But so when you're doing these kind of complex physics type simulations, sometimes we have to iterate with tests to kind of dial the model in. Is this form of simulation like that, to where I need to do some physical testing to kind of definitely characterize the material properties, but maybe some other things to make sure my model's good? Or is it pretty accurate without any physical testing?
We definitely complement physical testing. Things like single event upsets are hard to simulate on the system level. And so the typical test involves taking your device and putting it in front of a beam of high energy particles and seeing how the upset response looks like and the failure looks like for the device. That kind of test is probably not going to go away anytime soon. But if we can complement the simulation, the test with simulation in various ways, right? The first thing we can do is we can go to energies or particle types that are beyond what you can get in your test facilities. We can very easily reproduce the test setup as well with the exact beam profile to calibrate things before you start doing design changes in your simulation. There's a lot there, right? Because, for example, we can run an analysis for a 15-year exposure. You're not going to do a test that's going to last 15 years, or else you're never going to get your mission out of the door, right? So simulation opens up a lot of opportunities on that front. But testing is not going away, and we definitely position simulation as a very good complementary to the test tool.
Cool. I could talk about this a lot more.
Me too.
Because it just opens up a lot of questions, but hopefully this gives a little bit of a high level intro to folks. Is there anything that you wish I would have, before we move on, is there anything you wish I would have asked that I didn't, that you want to make sure our listeners hear?
I think one thing that we're very excited about in terms of the technology and how we simulate these problems is that we are getting a lot of advancements in hardware computing technology and a lot of simulations that were a little hard to get done because of the amount of compute power that you needed to do are becoming more and more accessible through GPU acceleration.
Right.
And EMA is working very hard to GPU accelerate our radiation transport code. We already have a workflow that leverages GPU acceleration for what we call ray tracing, which is kind of a simpler workflow for the radiation transport and the ionizing dose calculation. But now we're actually able to also do the full radiation transport physics on GPU, which is and the speeds are pretty ridiculous and mind-blowing in terms of how much more you can run for statistics and how big geometries you can take on.
Yeah, it's pretty amazing how GPUs are changing everything. Are you guys using a Monte Carlo at any point with this?
That's what the radiation transport code. It is Monte Carlo.
Yeah.
We get an energy spectrum of electrons and ions, and we position it in a given location. We have to select one particle with a random energy and a random location, and then look at all its physics on the system. And we repeat that process with, let's say, 1 billion particles to get the exact effect on the target.
Hence the need for more compute power. Yeah, I see
Hence
that.
why the more you throw at it, the more accurate it's going to be.
Yeah. I love it. John, do you have anything that I missed?
Yeah, there's probably one more thing. It's not specific to this topic, but it's another electromagnetic environment that you need when you're considering space missions, and it's before you ever get off the ground. As you can imagine, a launch pad is a giant lightning rod.
Yes.
And the equipment, as it's sitting there waiting to launch, must survive lightning strikes, and so that's typically both Charge Plus and EMC Plus can help with that. We have a lot of experience in that. We put together with Ansys, did a very exhaustive space series that walks through just across the entire mission, all the different electromagnetic threats. But lightning is a significant one before the mission starts.
Yeah, forgot about that. It's a really, really significant one. Cool. Tyler, anything else you want to add?
No, I mean, we're approaching the part where it's sort of out of my depth as we get to the complex physics and the everything. It's a fascinating piece of software. EMC Plus and Charge Plus. I've been slowly getting used to it over the last couple of years as it's getting more and more integrated into the Ansys ecosystem, and it's a fascinating, powerful piece of software. I'm excited to use it more, and this has been a very enlightening discussion. Good.
Well, I'll make an appeal to our listeners who are PADT customers to go ahead and take a look at adding this so that Tyler can get more experience with it. So it's a win-win in that situation. I'll add before we wrap up. I'm seeing this not only in this area, but even Chalk and Vibe. I'm really excited about commercial space and all the applications. But one of the things I'm finding, back to what Kevin said earlier, was I don't think that everybody's they're focused on what their module does on the spacecraft, and they're not looking at, they have to survive launch, they have to survive the lightning strike, like John said, they got to survive the radiation environment, and there's a lot of standards out there. And if there's anything that I can get across to anybody listening that's new in the space world, is you got to know what these things are and these requirements are. Yes, your product has to do what it's supposed to do, but also it needs to survive this very harsh environment of storage on the ground, launch pad, launch, and then of course on orbit, and sometimes even reentry. We're getting into more and more customers are like, oh, we're bringing our payload back. We have to survive reentry. So that's a whole other issue of plasma and hypersonics and things like that. So it's a lot of fun. I really, really appreciate it. This is a growing topic. Love all the new things that are going on in it, and love the partnership with Ansys. We always like to see that. We will definitely put some links into the notes for folks to be able to reach you. But John, what is the best way if anybody's got specific questions about the EMA products for them? Who should they reach out to?
They can reach out to me directly.
Okay.
I can be reached at john.twerdok, which is TWERDOK at ema3d.com. Just go to our website, which is ema3d.com. Certainly, we respond to people all the time there, and we get a wide variety of inquiries there.
Great, excellent, very, very good. And again, not just for the simulation side, but the test as well. So that's good to know. More and more needed. All right. Well, appreciate your time. Thank you for jumping on with us and educating myself and Tyler a little bit about this topic. And we hope to talk in the future about more and share some more customers. So thanks very much.
Thank you for having us.
Yep. Thank you, Eric.
Thanks. So hopefully that was enough to get your interest going. As I mentioned, we are going to talk a lot more about them. PADT is going to talk to them more about testing as well for our own work. And it's great stuff. As we work through the revolution in commercial space, we're seeing out there more and more tools for that area. And it's kind of a neat thing to see. So, many of our customers who need this kind of simulation capability and everything else that Ansys does are startups, right? So we thought it would be a good time to remind everyone about the Ansys Startup Program. The program gives early stage companies access to the full suite of Ansys products with no limitations at a price they can afford. And if you join the startup program through PADT, you also get access to the business and technical expertise we can bring to the table as well. So if you're in a startup or know someone in a startup in Texas, New Mexico, Colorado, Utah, Nevada, California, and of course, Arizona, reach out and we'd love to work with you. Let's talk and find the right package for you so you can drive your product innovation and virtual prototyping with the best simulation tools available. And yes, it is a violation of the license agreement for you to use any kind of university seat and your day job's seat. So if you're using that for your startup, you might get caught. So a lot of times people do that because they think they can't afford Ansys products. You probably can. So reach out and let's talk and figure out what we can do to get you the tools you need to move your product forward. So always a good thing to talk about the Ansys Startup Program. Please share it with people you know if you're not in a startup, but you know people who are. All right, let's move on to news. We always start with stock. And of course, now after the merger, we're looking at Synopsys stock. So if you remember, their stock had a bit of a fall in September and again in November. Well, that's been correcting itself kind of slowly. Nice little ramp up. And they've been growing ever since. They're back to their level they were before 2024 price, when there was a lot of speculation about what they'd be doing with the Ansys acquisition and other things. So that's been a really good thing to see. So they're sitting at $511.30. Around 11 o'clock Phoenix time on 1/28/2026. That is a 6.4% jump year to date, and which is only 28 days, right? So good start to the year. The S&P 500, just as comparison, is only up 1.87 so far. So we'll continue to watch this and let you know how things go through the year. So news-wise, the first one is stock-related, and it has direct impact on what that price is going to be because they're releasing their Q1 numbers in February 25th of this year. So I don't know if you know this, but they don't run a calendar fiscal year. They run a fiscal year that starts in November, I think, and maybe it's October. I can't remember. But anyway, it's not. The year does not end in December. It doesn't end at New Year's Eve, which is kind of nice for us from a bookkeeping standpoint as well. So we kind of like that, but so their announcements on their stock, how their performance was, are going to be a little off from the normal stuff. So their Q1 is going to be in February instead of April, like most people. And that's it. I probably need to dig a little bit more. I'm not finding a lot of news out there. I don't know if they just don't put out as much as Ansys did, or I'm looking in the wrong place. And I certainly didn't find any news that was kind of Ansys related other than the normal, we're doing great things with these customers type things, but no news worth sharing here. So I'll keep looking and keep working on that and figure that out. And the same goes for PADT. We don't really have any news to share with you as well. So moving on to the next thing, which is my pick of the 3 best Ansys blogs that you should be taking a look at. So if you're new to the podcast or don't remember, every episode I go and I peruse the Ansys blog, which I read pretty religiously, and pick 3 stories that I think other people should read. And the first one I want to pick is because I love non-traditional industries, right? We're used to aerospace and medical and electronics and things like that. Well, there's a really good article on creating better fragrances with simulation. So it's about the simulation tools that this fragrance company uses to get a better mix and other things like that. So pretty cool read. I love that application. Another really cool application, and it uses 2 tools I love, is called Robotic Startup Gives Construction Workers a Safety Lift with Automation. And they basically are using Ansys mechanical, structural, and multibody dynamics to model this kind of robotic safety lift for building stuff. And it's a pretty cool application. Definitely check that out if you're on the mechanical side of things or interested in such things. And then the last one that I picked, because I also have a sweet spot for any kind of interplanetary exploration stuff, is the Future of Space Optics with Scanway's modular payload solution. And so it's a real look at using the Ansys optics type tools to help them design these things. All good articles, definitely worth reading. Check out the Ansys blog. I can never remember where it is, so I just type in Ansys space blog and it takes me there. It's great stuff. On our side, we don't have any Ansys related posts since we last talked at the beginning of the year here. But we do have 2 announcements we made. If you're here in Arizona or want to come to Arizona for AZ Tech Week, so this is our first year doing a week-long startup extravaganza for the whole state. And PADT so far is participating in 2 events for that we're hosting and co-hosting. The first one is going to be on basically helping people who are startup members or want to be startup mentors how to be better mentors. And then the second one, which is much more applicable to Ansys, is a hard tech session. It's basically about a 4-hour session. We're going to talk about the Ansys startup program as part of that and how to drive your design with simulation. And then we're going to talk about raising money for startups that are hard tech, and then kind of the founder's journey. Doing a hard tech is harder than a software company. And we're going to talk about that and do some networking and things. So if you're on the hardware side of things and you're in Arizona that week for AZ Tech Week in April, come on by and see us. And then also, I mentioned it earlier, Harrison wrote a really cool article about what we did at CES. Check that out. He's got a great video of all sorts of robots and things. It came out really nice. So check that out and learn more about what you missed at CES. Even if you were there, you missed stuff, right? And then let's see, upcoming event-wise. Let's take a look at the PADT website. So if you ever want to know, you can just go to PADT, About Us on the top menu, and then Events. And we are pretty busy coming up here. If you, again, are here in Arizona, tomorrow is the Arizona Technology Council Board of Directors quarterly meeting, and we have our first VIP mixer after that. So it's always a great place to meet the members of the Arizona Technology Council Board, which I'm an emeritus member of. And then I will be in Anaheim for the MD&M West. They finally settled on a name, I think, for that event. And it's a combination of multiple different trade shows. It's huge. It's there at the Convention Center in Anaheim. And it's Tuesday through Thursday. I will be in the PADT booth the whole time. So if you're going, please stop by. If you are in Southern California and you'd like a free pass to the expo, reach out to me. We've got some that we can hand out. Got a code I can give you. That's it for that week. And then we've got a whole bunch of seminars that we're promoting for Ansys. And then our next big event is going to be taking a look at the 2026 Flynn Foundation BioCapital Conference here in Phoenix, which is a biotech conference that we go to every year. And then getting into April, we got all kinds of other stuff going on that, including Startup Week and also the Space Symposium. We'll be at the Arizona booth again this year for that. So check all of that out on our website. There is an Ansys event I wanted dimension. So with the merger or the acquisition of Ansys by Synopsys, they're also combining their user conferences. So I guess they called it the Synopsys User Group or something like that. I can't remember now. But Silicon Valley Simulation World was an event we already had on the calendar. So they're merging that in with the Synopsys event. So it's all going to be one thing on March 11th through the 12th at the Santa Clara Convention Center. So if you're in Northern California, I definitely recommend you check that out. Whether you're a Synopsys user or an Ansys user or both, it's going to be a nice event, nice and big, lots of people there. So I'm not quite sure what our presence will be, but we'll definitely have some folks out there and would like to stop by and say hi. So again, that's March 11th through 12th. And that's it for this episode of All Things Ansys. I want to thank you, as always, for giving it a listen. Hopefully you find it useful and entertaining. Please don't forget to subscribe and to like and all that stuff that the influencers say. It helps us get recognized by the algorithm. And also don't forget to subscribe to our newsletter at padtinc.com/opt-in. You can get our newsletter once a month and see what's going on and links to other things and what our customers are up to. And we've redone our newsletter. So now we've got a really cool section that is pictures. So it's basically photos of what we're doing out and about during the month. So people seem to really like that a lot. So as always, please spread the word about the podcast and don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 140. As a reminder, this podcast is not affiliated in any way with Synopsys, and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.